Okay, so for the beginning of the review, I want to just go over the basics of a mineral and the different physical properties of a mineral, because those are what we are going to need to review for the short answer part. So remember that the minerals are the building blocks of basically everything. Currently, there are 5,413 minerals, but only 20 minerals make up 95% of all the rocks. And then to go into the definition of a mineral, the 6 things that you need to remember for the definition of a mineral are that they are naturally occurring, they are macroscopically homogeneous, they are solid, there is a definite chemical composition with every mineral, and there is a crystalline structure, and they are inorganic. So those are the 6 things that you need to remember. They are in the PowerPoint on Canvas, so you can go look at that if you need to. So that is the basics for the mineral, and now let's go into physical properties. So the physical properties, as you know them, you know what they are, we tested on them, they're good. But I'm just going to go over a quick definition of each one of those and something that you would need to know about. So color, everything can be in multiple colors, but other minerals can only be in one. So it's really weird because there's some minerals that are multiple and some that can only be in one, and that's why color is the least helpful physical property to kind of use. And then remember with, this isn't really with color, but I'm going to group it there because I don't really know where else to put it. Remember the difference between opaque, transparent, and translucent. So just do a really quick review of that. To be opaque is the one that you cannot see through. And then translucent is it's kind of see-through, but like foggy, like looking through a looking glass or something like that. And then translucent is looking through, and it's like looking through a glass window. You can see through it. It's clear. It's fine. Yeah, good. So those are what you need to remember about that. And then with crystalline systems, just remember it's the mineral's symmetry. And with the 6th one of those, unless you're having a lot of trouble with identifying, I would rather we only talk about those when we're talking about what each one in the kit is for identification, because I think it's better on some cases for a little bit of memorization rather than identifying with the part that she's going to give you, because like she already told us in class, is that we're going to have the 20, I think it was, minerals, and you have to pick it up and identify it and then tell one thing that she asks about it. So it could be like, what is the hardness? Or you could say the crystalline structure. And then you have to circle which one you're saying. So like, oh, the hardness is 9, or the crystalline structure is hexagonal. And that would be for corundum, which I'll go more into minerals later. But so that's that. And then remember that the habit is the ideal shape or appearance of a crystal face. So the ones that I would kind of focus on that, and that one is more, you should remember them and know how to identify them rather than memorizing them. So this is more about like knowing them and being able to recognize them within a sample. So bladed, banded, coliform, massive, equant, and druzy are the ones I would focus on. I would also say micaceous, but I'm pretty sure micaceous, you know that one, so you're fine. So let's go into luster. So luster is the appearance in reflected light of a mineral, and it's either metallic or non-metallic. And I would go over some of those more, the dull metallic, shiny metallic, vitreous. And then the other non-metallic ones, like vitreous, the soapy, earthy, greasy, pearly. So with luster and habit, it's probably going to be an and situation, because those are things that you should be able to look at the sample and identify rather than have memorized about a sample. So those are ones I would know the options, but you don't need to like memorize that this one is this one is this one is this one is this. If that doesn't make sense, email me or text me and we'll talk about it. Okay, and then remember that the streak is the color of the mineral and powdered. You will have streak plates, magnets, and glass jars at every single station, so we'll be able to test that every single time. Okay, next one. What?
Should be acid.
Oh, there's acid at the front, but it's not at every single table. Okay, sorry, Anthony's in here too. And okay, so then we have the cleavage and the fracture. And I'm not going to go over hardness because you know hardness, you're good. So cleavage and fracture. So the cleavage is the tendency to break along a plane of weakness, and fracture is how a mineral breaks when there are no cleavage planes. So those two are kind of important to know, like the differences, like know what they are. So yeah, there are some where you will have the option to talk about cleavage, but if you are not confident in it, you are not going to be forced to do that, which is something she told us. So like I said, I'm not going to tell you anything like super specific, just things that are general and things that she told us. So okay, so that is everything for the review, and now we're going to go into each mineral specifically, reviewing it and looking at what I think is good to have memorized for that specific mineral. Okay, so let's start with, I have the list right here and I have them all laid out, so I'm going to be moving around. Okay, so let's start with the native elements, and so the first one we're going to look at is copper, and so for this one, this is the sample of copper that I got. It's a little, sorry. So this is copper, which you know. So the things about copper that I would memorize or I did memorize, is that it is a native element and that it is isometric. So its crystalline structure is isometric, and its native chemical composition is a native element. So that's what I would do for copper. Next one is graphite. So let's look at graphite. You know it. Any of these that you're like, I know this, move on. Just skip through, it's fine. It wouldn't hurt my feelings. Okay, so graphite is also a native element, and it is a hexagonal structure, which that one is a little, for me at least, it was hard to remember because it's always so beaten up that it's never really looks like a hexagonal structure. So graphite is hexagonal. Okay, and the last native element is this one, which is sulfur. So you know sulfur. I keep angling it down to get a better lighting for reviewing it, because it looks kind of pale on the screen. Sorry about my bad nails. But it looks kind of pale on the screen, so it's not the best, but it's okay for review. So the thing about sulfur is that it is a native element, as I stated before, and it is also orthorhombic. So this is an orthorhombic crystalline structure, not crystal system. Anthony's making faces. Okay, and so pull them up. Just to review, copper is a native element with an isometric crystal system. Graphite is a native element with a hexagonal crystal system. And sulfur is a native element with an orthorhombic. So orthorhombic, hexagonal, isometric, native elements. Okay. So next we're going to move on to the sulfides. And I'll talk about it a little bit more later, but remember that there's sulfides and there's also sulfates. So they're different. Remember sulfides versus sulfates, and I'll talk about the sulfates later. Right now we're going to go over the sulfides. So the first sulfide is chalcopyrite. So here is a review for chalcopyrite. Oh, it looks awful on screen. Okay, so remember that chalcopyrite is the dummy's gold, where only like a dummy would think it was gold because it's basically a spray painted rock. So if you have something that looks like a rock with like chips of gold spray paint and stuff on it, that is chalcopyrite. So chalcopyrite is the chemical composition, the chemical classification of sulfide. So it is a sulfide and it is hexagonal. So sulfide and hexagonal is the chalcopyrite. So I'm going to flip it over here. I'm going to put these. Okay. And the next one on the list for sulfide is galena. So you know galena pretty well. I'm going to put it up here because I think it looks better. So you know it. And you can tell from most, and from this one especially in this break right here, about its isometric. It is isometric for its crystal system. So galena, remember that it is a sulfide and that it is isometric. And isometric is one of the easier ones that you'd probably be able to tell with the samples that are on the table. So just remember that. Okay, next one is fool's gold. Fool's gold rather than, I wish the lighting was better. Okay, fool's gold rather than dummy's gold. So it's something that's a little bit more tricky. I'm trying to make the lighting better for, no, that's worse. Okay, so here we go. You know what pyrite looks like. Maybe come in a little earlier just to do a quick review of just looking at them. I didn't, and I was okay, but, okay. So pyrite is a sulfide, and it is also isometric. Remember about the twinning that we looked at, where it had the pyrites that were almost perfect squares? That is how I remembered that it was isometric, and that's how I remembered. Okay, so remember with pyrite, it is sulfide, and it is isometric. Okay, and then we have one more, and this is the kind of difficult one with the sulfides, is the sphalerite. So the sphalerite is one that it really doesn't look like it'd be isometric, but it is. You can kind of see in some of the breakage points right here. Some of the breakage, and see how it's breaking in with like squares. Ooh. Okay. So this is sphalerite, and remember that it is a sulfide, and it is an isometric. So isometric and sulfide. So that's what you need to remember about this one. So those are the sulfides. So quick review. chalcopyrite, which is chalcopyrite, which is a sulfide, and it's hexagonal. It is the only hexagonal mineral of this group. Chalcopyrite, sulfide, hexagonal. Galena, sulfide, isometric. Galena, sulfide, isometric. Pyrite, sulfide, isometric. Pyrite, sulfide, Pyrite, sulfide, isometric. Pyrite, sulfide, sulfide, that's why it's hard. Pyrite, sulfide, isometric. Sulfide, isometric. And last but not least is the sphalerite, which the sphalerite is also sulfide. Sulfide and isometric. Sulfide, isometric, sphalerite. Sphalerite, sulfide, isometric. There you go. So that are the sulfides. So I'm going to try and fit them all in my hand like I did last time. Okay, so these are all the sulfides. Galena, pyrite, chalcopyrite, sphalerite. Sulfide. Fide. Sulfide. Okay, and now we will be moving on to the oxides and hydroxides. So the first one is corundum. So this is one of the uniquer samples of corundum, but this one is the main one that really helps you with all the things. So I'm going to focus on this one. So it is hexagonal, as you can see. Let me pull it down a little bit. Okay, it is hexagonal, as you can see. One of the things with corundum is to, okay, go away phone. Okay, I'm going to start this one over again. Okay, so now we are going to move on to the oxides and hydroxides. So the first one is corundum. So this is the kind of unique and a little confusing corundum sample. So I'm not going to focus on this one because it's a little uniquer. So I'm going to focus on this one. So this one is corundum. The nice thing to remember about corundum is it's one of the ones on the hardness scale. So it is 9 on the hardness scale, and it is hexagonal. Okay, so corundum is hexagonal, which you can tell by looking at the sample like this, and it is in the oxide and hydroxide category of chemical classifications. So this is corundum. And the next one we will be looking at is the limonite. So this is the limonite. And remember with limonite that we have the kind of sandstone-like kind of colors that are in it. So you'll see that there. And it's one of the like earthy kind of massive ones. So that is the limonite. And then for it is an amorphous crystal system. So it's the only amorphous one we have in the non-silicate minerals. This means that there's no definitive symmetry in this mineral whatsoever. So it is amorphous, and it is in the oxide and hydroxide chemical classification area. Okay, and the next one is the goethite. So remember that one is the weird geothite kind of spelling weird thing. So this one, remember kind of the layers of the earth, and then also this sample doesn't show it very well, but it has the bubbly chloroform and kind of stuff like that. That's a really good thing to remember for identifying it is the bubbles in the chloroform habit. So yes, this is that. This is goethite. Goethite is an orthorhombic. So it is an orthorhombic, and it is in the oxide and hydroxide chemical classification. So yes, next we will go on to hematite. So this is the specular hematite. Remember that hematite also has that red one that's only in one of our samples. It's all getting all over my laptop. Okay, so remember we have the red one and the specular one, and that can occur in the same sample. Like, it doesn't have to only be specular or only be this. It's a really weird mineral. But it is hematite, and it is hexagonal, is its crystal system, and it is in the oxide and hydroxide category. So there we go with that. Okay, and the last one in the oxide and hydroxide chemical classification area is magnetite. So one of the biggest things with magnetite, and just using it, is magnet. Use magnet. It always helps. Okay, so magnetite. Okay, so magnetite is an isometric. So you can kind of tell that with these sides right here and how they're more square. You can see that in this kind of side right here. So it is an isometric, and it is an isometric oxide and hydroxide within that category. So this is magnetite. Okay, and now since we've done that, we're going to move on to the three halides. So remember that it is halides and not halites or anything like that. Halite is the mineral, halide is the chemical area. So the first one we're going to look at is fluorite. So you can see, and remember, fluorite has the kind of translucent, kind of see-through, not very see-through, stained glass kind of ish way about it. It is an isometric halide, so it is an isometric halide. So yeah, that's fluoride. Remember with fluoride that the hardness is 4. I would say with any of the ones that are on the scale, like they are H equals, I would say do that one. Memorize that, like, that's a 4. So I'll go over that again at the end of the video. I'll go over the saying that I created for it. I don't know if it'll help you. It's really weird. I don't know why it helps me, but it does. And with each one that is on the scale. So fluorite is fluor, it is a halide, and it is isometric. Okay, so the next one we are going to talk about is halite. So this is halite. You know your halite. Thing with halite is it's a halide. Halite is a halide, and it is isometric. Isometric. Okay, so that's that. And then we have this one, which is sylvite. So sylvite is, remember we said that there was some of it, we remembered some of it in the Hutchison salt mine and accidentally took some of it home, not realizing that it wasn't just salt. So it is also isometric, so it is an isometric halide. So you might have noticed that all of the halides are actually isometric, so it's a pretty easy thing. These are the only 3 halides, and they're all isometric. So it's pretty easy. So here you go. Look at them. Ooh, fluorite, halide, halite, all halides. See, it's a little difficult. Okay. Halides, fluorite, halite, sylvite, halite, fluorite, D halides. Okie dokie, okie dokie. Okay, so those are those, and I do recommend using the exam list of non-silicate minerals. That's what I'm using to look off. It has coffee stains on it because I was studying with coffee. But there you go. So I do recommend using that and maybe putting all the information that you want for each mineral next to it. So mine specifically is the crystal systems next to all of them. Okay, carbonates. Let's move on to the carbonates. So the first carbonate we're going to look at is azurite. Azurite. So this is one that you were pretty comfortable with the last time we've talked. It's the one that's blue within this rock. Okay, so it's a carbonate, which means that it will fizz, and next to every sample that fizzes, there will be the acid that you can use if you want to, but she has put on the quiz, like, this one fizzes, this sample fizzes, and so you don't actually have to test it if you don't want to. So just remember that these next ones all fizz. So if you memorize the ones that fizzes and it says fizz, you already have narrowed it down from the possible 25 minerals to 6. So azurite, it fizzes, it is a carbonate, and it is monoclinic. Monoclinic, carbonate, fizzes, azurite. Okay, and the next one, it is the multi-sampled. So it is the multi-sampled calcite. So again, with one that is on the hardness scale, calcite is number 3. So it has a hardness of H equals 3. These are all the different ways that calcite can be presented. Break my keyboard. Okay. So remember, calcite is a carbonate and it is hexagonal. None of these really show that, but you can kind of see it in this one. Oh, it's not really focusing. So you can kind of see it in this one of it being hexagonal, but it is a hexagonal carbonate and its name is calcite. Calcite, the hexagonal carbonate. Awesome. Okay, so the next carbonate is the aragonite. So remember, it's the one that has the kind of spidery legs, but also appears in this form. So it is aragonite. It is orthorhombic, and it is also carbonate. So it fizzes. It is a carbonate, fizzes, and it is orthorhombic. Orthorhombic, carbonate, fizzes, aragonite. And next one is one of my favorite with our stupid memory things, is the peachy glass shards. So this is dolomite. So this is dolomite, the mineral, obviously. It is carbonite, so it does fizz, and it is hexagonal. So it's really hard to see with all the twinning that is occurring in here, all the penetrating twinning. But it is dolomite and hexagonal. Dolomite, hexagonal, carbonate. Dolomite, hexagonal, carbonate. Awesome opossum. There we go. And the next one is the malachite. So malachite, M-A-L-A-C-H-I-T-E. There you go. It is the green one. So if you want to look at it, here you can see. That's better. Okay. It is monoclinic. So both this one and the azurite are the carbonates that are monoclinic. So monoclinic, carbonate, it'll fizz, its name is malachite. malachite, carbonate, fizzes, monoclinic. Okay, and last but not least, we have the ridiculous rhodochrosite. We have the ridiculous rhodochrosite. So rhodochrosite is hexagonal, which is not really apparent in all or any of these boxes, to be honest, any of the mineral boxes that they have. I don't think it's very apparent, but you can see the pale pink color isn't really coming off on camera, but that's the main identifier of it, really, is the pale pink. It is hexagonal, it is a carbonate, it fizzes, it is hexagonal, it is a carbonate, it fizzes, its name is rhodochrosite. RHODOCHROSITE. And the way she had us with the kits and everything memorize it is with CH. It is spelled in other countries with just a C, which is how she accidentally spelled it on the exam list. However, she won't count off if it's CH or C. So however you have memorized it before, just continue with that. It gave me a scare when I saw it spelled weird on here, but just to let you know. Okay, so that is all the carbonates. So to review, if it says fizz on the test, that means it fizzes, and so it has to be azurite, calcite, aragonite, dolomite, malachite, or rhodochrosite. Those are the only 6 out of the 25 that fizz because they are carbonates. This is them. Get them all in the picture, sorry. They're the largest group, so, okay. Aragonite. Aragonite is orthorhombic. It is an orthorhombic carbonate, and its name is aragonite. Rhodochrosite. Rhodochrosite is a hexagonal carbonate. It is a hexagonal carbonate. Dolomite, the peachy glass shards. Dolomite is a hexagonal carbonate. Hexagonal carbonate. Okay, so it'll fizz like all of these. Calcite. Calcite is another hexagonal carbonate. It is hexagonal carbonate. Its name is calcite. It fizzes. There it is. Malachite. Malachite is one of the monoclinic. The other one is here. So azurite and malachite next to each other, the differences. And they are both monoclinic and they are both carbonates. Azurite, carbonate, monoclinic, malachite, monoclinic, carbonate. They fizz. Whoops. I'm trying to pick them all up. Okay, that worked. These are the ones that fizz. Okay. Okay, and now on to the other one that's a little difficult, is the sulfates. So there's only three sulfates, and why there are 4 sulfides. So the sulfates are, the first one is barite. So this is one that we didn't really focus on. Of barite, we kind of focused more on the, I'm just breaking my laptop, bare butt one, of barite. Remember that it also comes in these forms as well. So this is barite. It is an orthorhombic sulfate, an orthorhombic sulfate. Okay? Okay. And gypsum is the, oh, Barrett's still here. Gypsum is the next one. So this is the most common appearance of gypsum that we have looked at in class, but it also comes in this form and this pale pink, not fibrous, but very lined, if you know what I mean. All the little lines, pale pink form of gypsum, and then this kind of just looks like white gravel rock gypsum. So gypsum is monoclinic sulfate. It is the monoclinic sulfate. You can really see the monoclinic in this one right here, which is also the most common one. Monoclinic sulfate gypsum. Oh, and gypsum is also one that is on the hardness scale. So it is the other one that you should know that it is 2. So hardness scale, it is equal to 2. It is gypsum. Okay, and the last sulfate is this one. Your favorite, I didn't get a kit one that has the same like weird lavender thing that you love so much. That I don't know if it would show up on camera either way. But it is the one with the multiple crystal faces, and of course I am talking about anhydrite. So the weird little lavender anhydrite that is lovable and amazing, it is a sulfate and it is orthorhombic. So a sulfate, orthorhombic, anhydrite. Anhydrite, no water, pretty lavender, orthorhombic, sulfate. Okay, so the sulfates, the 3 sulfates are right here. Barite, which is an orthorhombic sulfate, barite. Anhydrite, with its multiple crystal faces, it's pretty lavender, orthorhombic sulfate. Orthorhombic, sulfate, anhydrite. Orthorhombic, sulfite, anhydrite. This is gypsum. Gypsum is the monoclinic sulfate. Monoclinic, sulfate, gypsum. Gypsum, monoclinic, sulfate. Okay, and we now only have one mineral left. So, what? I'm trying to pick them all up with my hands. Anthony's laughing at me. It's a great time. Okay, so we only have one mineral left, and that is apatite. So this is apatite. Remember we talked about it's the snotty colors that are unappetizing and gross, and you wouldn't want to eat it, and so it's apatite. It makes you lose your appetite. So those are the colors of apatite. Those are the ways to remember it. It is the only phosphate mineral. Apatite is the only phosphate mineral, and as the smaller ones that we always do clearly show, well, shoot, the camera's kind of blurring it a little so it looks like a circle, but it is hexagonal. It's pretty obvious in all the samples when you're actually holding them of the small ones that it is a hexagonal crystal system. So the only phosphate is apatite. It is hexagonal, and it is another one that is on the it is another one that's on the hardness scale. It is number 5, so it has a hardness of 5. Yeah, I have it here. I just don't have the numbers written next to it. That's why I was like, had to count real quick to be like, it's the 5th one. So yeah, that's the last mineral. It is apatite. It is phosphate. and it is hexagonal. It is hexagonal, it is phosphate, it is apatite. It is apatite, it is hexagonal, it is phosphate. Okay, so I talked about some other ones that I was thinking about. I don't think I don't have it with me. I don't have it with me, so to review it, because I didn't know I'd be doing this today. It's in a folder in my apartment. But the other things I think you need to look at are the tenacity. So the tenacity, or think of the stress strain diagrams that we did in environmental, where there's like the malleable, there's flexible, there's ductile, there's brittle, all of those. Just remember that that's tenacity and what it is. So I don't have the exact definition in front of me, but I would remember that it's the amount of stress it can have before breaking, kind of thing. I would look on the PowerPoints to know the exact definition, because like I said, I'm not reading it. Look through your notes, look through the packet that she gave us for properties. So that's something I would know. And then I don't think I can do this backwards, but I will write it out. So I don't know if I've shared with you before, but for hardness, the things that I remember is from 10 to 1, so you start at the top and go down, is Dr. Cooper took Quentin's oranges and fruity gummy candies today. So that's how I remember it. Dr. Cooper took Quentin's oranges and fruity gummy candies today. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Diamond, corundum, topaz, quartz, orthoclase, apatite, fluorite, gypsum, calcite, talc. Okay, so that's one I would go over and remember. For me, it was pretty easy if I remembered that Dr. Cooper took Quentin's oranges and fruity gummy candies today. I could just write them out, and from that, I was able to look at them and figure that out, exactly what their hardnesses are. If it's not on here, you will have your fingernails and your glass jar to test, and you would just have to do a range rather than the exact ones. These are the only ones she's expecting to be able to do the exact thing, and every other one is like less than 2.5 or between 2.5 and 5.5 or higher than 5.5, and you will have all the stuff there to test it. So you wouldn't need to memorize that, like, this one is 4 point blah blah blah. You wouldn't need to memorize that. So this is what I remember. If you want to come up with your own way, or if you want to use mine, whatever works for you, but I would be able to do that. So there. That is it. If there's any specific ones you want me to video and go over, I'm going to ask you, and then I'd recreate more in-depth ones of those specific ones. So yeah, okay, I hope you're doing good. You're amazing, wonderful. He sucks, he's awful, he's good, he's not.
Wow.
How you Ouch!
You okay?
Yeah, we're stopping this now.